Students, we are given this question: dy over dx is equal to root of 4x positive 2y negative 1. So foremost, what I'm going to do is let 4x positive 2y negative 1 be equal to z. So differentiating both sides, we get, so what do we get when we differentiate both sides? This is 4 positive 2 times dy over dx. This is 0, differential of 1, and this would give me dz over dx. I can rewrite this as 4 positive 2 times dy over dx is equal to dz over dx. Now, in place of dy over dx, I can substitute dz over dx, but I need to do some alterations. So what alterations I would do? I would just keep dy over dx over here, and then I would have to move the quantity. Now, instead of obtaining for dy over dx, what I would do is I would use the value of dy over dx, which we know to be as root of 4x positive 2y negative 1 in, if I take this as 2, I will use it in 2. Okay, so in that way the solution can be simple. So dy over dx will be substituted here. So 2 will become, so therefore 2 is going to be dz over dx is equal to 4 positive 2 times, in place of dy over dx, I'm going to substitute root of 4x positive 2y negative 1. But root of 4x positive 2y negative 1 is equal to z. Okay, so if I were to take it as 3, so therefore 3 will now be rewritten as dz over dx is equal to 4 positive 2 times root of z. So this is what I am getting. So now I'm going to move this down and move this up. So it's going to be dz divided by 4 positive 2 times root of z is equal to dx. Now integrating both sides, this is an important statement you have to write. We get, so what do we get when you integrate both sides? Now this can be integrated by making the following substitution. So let me take z to be as sum u squared. So dz is going to be 2 times u du, and root of z will become equal to u. Okay, so what I'm going to do is I'm going to use this space here. So this implies integral, in the place of dz I would be substituting 2 times u du divided by 4 positive 2 times root of z is going to be u. So this is what I have got, 4 positive 2 times u. Now you can very well take a u out and make the substitution. So what I would do is I would just consider this first. Of course, on the right hand side you have got integral dx. I don't want to integrate it now. Let me first finish off this left side integration, and then you would be having a better idea. So what I would do is I would take 2 out from the denominator. That would be giving me 2 positive u in the denominator. In the numerator you have a 2 times du is equal to integral dx. Now clearly the u can be cancelled, giving me integral u times du divided by 2 positive u is equal to integral dx. Now I'm going to consider integral u du divided by 2 positive u. So let me take 2 positive u to be equal to some t. This would give me du is equal to dt. So I can rewrite this as, in place of u it's going to be t negative 2 times, in the place of 2 positive u it's going to be t, in the place of du it's going to be dt. So I can rewrite this as t dt divided by t negative 2 times integral dt divided by t. T and t can be cancelled, giving me integral dt minus 2 times integral dt divided by t. This is going to be t, this is going to be 2 times ln t, but the value of t is 2 positive u. Okay, substitute that. So this is going to be 2 positive u negative 2 times ln of 2 positive u. So this is what I get. So I can write it down here. So this implies integral u times du divided by 2 positive u is equal to integral dx is now rewritten as 2 positive u negative 2 times ln of 2 positive u. Okay, this is what I get. Okay, now this is equal to integral x. Okay, this is what is equal to. Now I have made the assumption, but if you would have remembered, I have taken z to be as u squared. Therefore u will be equal to root of z. Now I will have to make the substitution. Okay, now if I were to make the substitution, then clearly the following would be obtained. So this is going to be 2 positive, in place of u is going to be root of z negative 2 times ln of 2 positive z root z is equal to x. Now I will move this 2 to the other side. That would mean root of z negative 2 times ln of 2 positive root z is equal to x negative 2. Now I'm going to rewrite this as x, okay, positive of negative 2 on the left. Now since z is 4x positive 2y negative 1, I am going to use this over here. So that's going to be root of 4x positive 2 times y negative 1 negative 2 times ln of 2 positive root of 4x positive 2y negative 1. Okay, now this can be further rewritten. Okay, that is root of 4x positive 2y negative 1 negative 2 times ln of 2 positive root of 4x positive 2y negative 1 is equal to x. Now this is a constant, so I'm going to just place an arbitrary constant c. So that would be the solution for this question.